This is Math 7A, line of best fit. Essential question, what does the line of best fit allow you to do? So in other words, what's the purpose of having a line of best fit? Remember to pause this recording whenever you need to. A line of best fit. It's a line through the points on a scatter plot showing the direction of the pattern. A line through the points on a scatter plot showing the direction of the pattern. You make a line of best fit as close to the data points as possible. It needs to be as close to the data points as possible. Usually kind of right through the middle of the cloud of data points. Ignore the outliers. You shouldn't really pay attention to those when you're drawing your line of best fit. And then you can write the equation of the line by finding or estimating the slope and the y-intercept. So since it's a line, we can write an equation for it in y equals mx plus b form. And finally, make predictions with the line. That's sort of the whole purpose of making a line of best fit in the first place. Here is an example right here. So you have a line of best fit already drawn. Let's start by taking a look at what the y-intercept would be. So we're going to have to estimate. It's not perfect. We're going to have to estimate. So it looks like it's a like 780, I would say. So we'll go ahead and put that in. And then to get the slope, I'm going to go ahead and use that point as my first of 2 points. If I go find another point, I'm going to look along the line and try to find another place where it crosses a crisscross on the grid, and I kind of like the point that's over here. Oops, right there. So that is 100, 1000. So now to get my slope, I'll look at my change in y. That's 220. And my change in x, which is 100. So my slope then is 200 over 100, which I can simplify. I can just turn it into a decimal. That's probably the easiest thing to do on all these. Let's call it 2.2. So now my equation will be y equals 2.2x plus 780. Now that we have a line of best fit, we can use it to predict. So it says predict the sales from $200 in advertising costs. So if I look at $200 in advertising costs is my x variable, because here it is right on the graph that it is my x. So I'd have y equals 2.2 times 200 plus 780. So that's going to give us, let's see, that's going to be, let's see, 440 to move over 0 would be 44 plus 780. So y equals, that's 4, that's 12, carry the 1, $824 dollars in sales from that much advertising. Nope, that's right. Whoops, actually that's 440. Let's cross that out and correct that. That should be 0. That should be 12. Carry the 1. That should be 1,220. Okay, that's better. So that would be your sales in dollars. I caught my mistake by taking a look at the graph. I thought, that seems a little low, because if I'm going for $200 in advertising costs, that would be, you know, beyond my graph out here somewhere with 200. And so for it to only be $824 doesn't fit with the rest of my data. It should be increasing. So it should be somewhere out here. And so it makes more sense that it's 1220. Okay. Okay, so the next one, let's draw our line of best fit. Bear with me, I'm going to wing it with my stylus. You sort of want to have as many points above the line as below. And notice I'm ignoring this outlier right here, just kind of ignoring that altogether. Okay, so let's first start with our y-intercept. So it looks to me like the y-intercept is about, probably not quite 0. Let's maybe say 0, 10. And then for the slope, let's start by using that point, 0, 10. And then I really like this one right here. So that's 84, 225. So if we get our change in y, that's what, let's say that's 215. Our change in x is 84. Okay, when I divide that on the calculator, 215 divided by 84 comes out to about 2.5, 2.6. I'll go with 2.5, a little nicer number. Again, this is an estimate anyway. So then our equation is y equals 2.5x plus 10. Okay, we could use that to predict if we needed to. Okay, last one. So we're going to go ahead and draw our line of best fit. Again, bear with me. So for y-intercept, let's go with 0, 300. We'll use that as the first of 2 points that we used to find the slope. So if I look at the line of best fit that I drew for mine, and again yours might come a little different, I'm going to go ahead and use this point up here because this is the one that seems to be on like a perfect crisscross, so that's 45, 700. And if you don't have one on a perfect crisscross, estimate where it is. Okay, so if that's a 300 there, right? So that's 400 for my change in y and 45 for my change in x. So I'm just going to take a second here and actually divide that. So you can see it's going to be a little less than 10. Comes out to 8.8. So there's my slope, 8.8. You might even want to just call it 9. Again, we are estimating here, so maybe we'll just call this 9 for simplicity's sake. So now our equation is y equals 9x plus 300. So if we're going to predict the number of calories there are with 60 fat grams, the fat grams are our x, so we have y equals 9 times 60 plus 300, so y equals 540 plus 300, so y equals 840, and that's calories. Okay, so this is it for today. Have fun with line of best fit.